Donghoon Kim. He's a research scientist at LBNL in my division. Donghoon and I do several projects together. His background is pretty amazing. It spans HVAC systems, simulation design, of sort of cutting edge stuff. At the same time, he's also very well known for controls and optimal controls, specifically model control. So today he's going to talk to us about some of his work on HVAC systems. And in the future, we're not sure we're going to have him again for the controls topics. All right, Donghoon, take it away.
Okay, thank you, Marco. Hello, everyone. So this section is about regulation and application for air conditioning and a heat pump product. Is actually I prepared the slide as a kind of a subsection too. Unfortunately, as Marco mentioned, my colleague Niyar Sar, who is expert in regulations regarding the HVAC equipment product, he is a sick and not able to join. Uh, but I will try to kind of do my best. Okay. So why do we care about the low GWP, local GWP represent global warming potential, low GWP refrigerant? And just to give a reminder as a background, back in 1980s, there was a Montreal Protocol to phase out CFCs, such as freon gases, as you know. That's because of the confront of the ozone depletions. After that, we saw some significant shift from the CFC refrigerant to HFC refrigerant, hydrofluorocarbon. However, as time goes, we face the global warming, and it's like the temperature of the world is keep increasing. The Montreal Protocol basically made the agreement, so-called Kigali Agreement. So basically, they are focusing on phasing out HFC refrigerant as well because of their contribution to the global warming. Then within the U.S. AIM Act, basically that's the U.S. law uh, um, implemented by the EPA, Environmental Project Protection Agency. They regulate they are start to actually from now current days like from the January 1st to 2025, they start regulating HFC refrigerant. So it's not a future problem. We are actually at that stage of regulating the HFC refrigerant. There's some article. It's not just like there's a number of articles talking about these new regulations acting again now. Is basically prohibiting the HFC refrigerant in some several areas, manufacturing and importing such kind of the refrigerant, and that affects to our daily life definitely. And so, as Montreal Protocol phased out the CFC and shifted to the HFC, and now this kind of Kigali Agreement and the AIM Act, what's the next generation refrigerant and air conditioner to heat pump? That's I'm gonna touch briefly about that. It's a big topic, but I try to kind of provide some specific answers regarding what products are available, and what's the type and what's the refrigerant and such kind of stuff. It's gonna be the very high level. So first of all, in order to answer that question, so we have gone some market surveys and also the literature reviews in like looking at the article and a website and reaching out to HVAC manufacturers. And we surveyed 17 low GWP heat pump product, mostly GWP number less than 500, including those currently available in the market in the US or outside of US as well. And as I mentioned, we try to identify what's the new next generation refrigerant and what's the system type, their capacities, and market availability in the US. We have focused only on the residential and light commercial application now. Or which is less than 10 tons. So this survey is not very comprehensive, but at least to give some ideas about the general trend. And also, finally, I'd like to provide some of the product links for those of you who wanted to investigate in those new products. Okay, so this slide shows the current and upcoming longevity refrigerant heat pump product available in the U.S. The left-hand side shows the equipment brand and a system type, whether it's air to water or or the air to air heat pump or heat pump water heater, and also shows the manufacturers and market availability, the type of refrigerant, and their heating capacity. So this is kind of a key summary of our survey. Again, but available in the US, not excluding those available outside of the US. First of all, when we look at the manufacturers, you can see many large HVAC OEMs in the US are listed in here, including Trane, Carrier, Lennox, and Rheem. And they are some currently the majority of the refrigerant or their system utilize R454B to replace R410A in mainly, but we can also see a few products that includes R290, which is propane, and also the R744, which is the CO2. Um, the the R454B is kind of a natural transition for and a substitution for R410A. And this trend, although the result is not very surprising, this is kind of what we expected from the past the studies, but is a good to have a product list in detail, so all the link attached in this slide, and that should be available when the slides are shared with you. And next one, since we are also very interested in the ultra-low GWP refrigerant heat pump product, when we say ultra-low GWP, that means typically GWP number less than 10. That depending on who is the speaker, but I'm saying GWP number less than 10. That would include a synthetic refrigerant such as R1234YF, ZE, or natural refrigerant like R290 and R744, which is the CO2. And as you can see here, majority of a product using the ultra-low GWP refrigerant that are not available currently in the US. Although there's as I mentioned in the previous slide, there's a two to three product available with the ultra-low GWP refrigerant in the US market, but most of the product are available in the Europe or the Australia. That is mainly because the government regulations in the Europe are more aggressive than the US, I believe, and also the demand and incentives, those are different in the as compared to the US and the Europe. So I think, but still, the United States is catching up with the general trend with the Europe. The next slide will kind of summarize the different type air-to-air heat pump as opposed to air-to-water heat pump categories. And air-to-air heat pump, one of the common characteristics is that they are using the old R454B refrigerant. That's a GWP number less than 500. Is basically the try to improve the efficiency and considering the manufacturing cost of the equipment with the new refrigerant and also to meet the EPA regulations. So they ends up with R454B for the air-to-air heat pump on the left-hand side. While the air-to-water heat pump is as you can see, they are most of them are utilizing propane refrigerant R290. This makes sense because the propane is highly flammable. It's a three refrigerant, so people are scared about putting the flammable highly flammable refrigerant inside of home, and also there's the building code would not allow install equipment is having some significant charges of such a refrigerant. So this is kind of the key observation we found. Again, like it's not very surprising result, but it actually shows that the manufacturers stick to this kind of a general trend. R454B for the air-to-air heat pump, while the flammable refrigerant in the air-to-water heat pump, so that would be installed outside of the building envelope. Okay, I want to close this seminar presentation, but the one thing that I wanted to emphasize is, first of all, this kind of a new refrigerant is that causes safety issues. For example, R454B and 1234YF and also the R290, those are flammable refrigerant, either in A2L refrigerant or A3 refrigerant. And although we have the R744, which is a CO2, but it also raised some safety concerns regarding their requirement of high pressure. For example, CO2 heat pump could their condensing pressure could reach up to like 100 bar. Surprisingly, that means like that their pressure is could go up to 100 times of the atmospheric pressure. So there's also a significant concern of the safety because of the high pressure and also the leakage concerns as well. So okay, this is a key summary or a key presentation, a short presentation of mine. If you have any questions, welcome.
Thanks, Dong. This is really interesting. I have a couple of questions, and then we can follow up with what's in the chat, and possibly other people can ask. Um, so I saw a lot in your slides. R290 seems
Yep.
to have high potential, but at the same time quite a bit of risk. From a kind of research point of view, things that you're seeing, maybe projects funded by DOE or other entities, what are they looking for and what needs to be done to make sure that it's safe, in terms of research?
Yeah, one of the key research would be, I mean, the R290 heat pump is not a new product. It's like already has been developed before a long time ago, but it's not commercialized because of all the economic, the reasons and the COP stuff. Um, but because of the EPA regulations, there's like industries try to adopt this, going back to this refrigerant and designing a heat pump. In terms of research perspective, one key research area that I am focusing on, and also that is listed in the DOE blueprint published by the BDO. That topic is about the leakage detection. And in addition to that, EPA, although is not finalized yet, as far as I understand, but EPA also wanted to put some of the requirement of automatic the leakage detection in the equipment. So this is one of the key active area, I can say.
So what you're saying is that the to being able to install a system like that, they want the system to provide state of charge or other information about, possible leaks in the environment, so if there's an emergency or something, as opposed to just smell something odd and then. All right. What type of facilities can test these devices? I know at LBNL there's kind of an active area of research because traditional environmental chambers are not,
Yeah.
recommended for that. Can you tell us a little bit more about that?
Yeah, typical psychrometric chambers that has been utilized for evaluating the performance of the conventional heat pump with the typical refrigerant R410A, R134A. Those psychrometric chambers is not allowed to test a highly flammable refrigerant the equipment. So for to have such kind of the facility, one has to install like such of sensors to detect the flammability, and also install additional kind of a functionality and a device such as the emergency ventilation. So when something is detected, and it tends to open up the dampers and ventilate the psychrometric chamber air. So there are a couple of the additional requirement to be able to test such a equipment.
Thank you. There's a couple of questions in the chat, just to kind of probably get to a close unless people have other questions. One is about R32. That's it's in the table right there. But do you see this as a kind of short-term transition refrigerant, or is it something that is going to stick around for a while?
Um, R32, if I remember correctly, the GWP number is still like shown here,
Mhm.
675, still meets the EPA regulation. And I don't remember the EPA regulations timeline, but it is gonna be stay there for like several more years, but it seems like it's not a long-term solution where such as like the government or U.S. government, federal, including both federal and state government, wanted to move forward with.
Thank you. Um, Patrick is informing us that actually the refrigerant doesn't smell. So uh, my comment was not appropriate in that case, and that there needs to be mitigations, detection methods that.
Yeah.
Um,
And
it-
R32 is also, as far as I remember, is also A2L refrigerant. So there is a mildly the flammable as well. So that it also raised the same safety concern.
Thank you. One last question was about the kind of phase out of the R410A or variable refrigerant flow system. Is there specific concern for those systems, or they behave like the other, they kind of
Yeah,
the.
that's really a good question. Unfortunately, I don't remember the specific EPA regulations regarding the VRF system, but there is a regulation regarding the EPA. Again, like I don't remember, but I can find out some of the link, or you can Google it. You can find some regulation regarding the VRF system. But as far as I know, the regulation is different between the typical the unit and the VRF system.
Thank you. Any more questions from either the chat, anybody want to raise their hands and they can ask directly? All right. Well, sounds like we're good. Thanks for the overview of existing products that are on the market right now. This is pretty exciting. It's not like just only research. And we look forward to see, more experiments on these and see how they behave and performance and everything.
Thanks so much.
Thank you, Don Hung, on behalf of everybody, and thanks everybody for joining. See you in the next
You-
one.